Hi everyone. So I'm Umesh. Today I'm going to present RAG-based applications, how to create them, and what is that in today's session. So let's get going into it. So here it bit about myself. I am Umesh. I am with Cloudera since 8 years now, and I am primarily working as a backend software engineer. With microservices, databases, and their performance tuning part, right? Um, and I have also contributed to some of the open source project while my tenure at Cloudera. These are Spark, Flumi, and Kafka. Um, Before working with Cloudera, I was with some of the data intensive companies, primarily worked as software engineer in India as well as in USA. I have done my MCA from IIT BHU. So this is about me. Here is the agenda of today's discussion, which I'm going to have. So I'll be discussing about what is RAG, essentially, and how to design the RAG-based systems, and some building blocks of it. And in the end of this session, I will be going through with the demo of the RAG-based applications. One of the use case of RAG is search in my demo. So I'll be covering that. And the major ground rule of this discussion is let's keep the questions and discussions at the end of the slide deck. Um, okay, cool. So, all right, let's discuss about RAG. What is RAG and what are the building blocks of it? So, RAG is a phenomena where we leverage the context which we get from the vector databases to feed into the generative models to provide the context and to output the more suitable and more accurate result sets from the generative models, right? And how do we get the relevant result sets from the, in the RAG? So the result sets are being stored primarily in the vector databases, or let's say the document store like file systems, S3. And from there, we retrieve those relevant docs and feed into the generative models to get the high quality of output. As you can see, by providing the relevant context to the generative models, we can minimize the hallucinations and provide the high quality of response, right? Uh, the majority of the use cases can, for RAG, can be the question answering systems, the chatbots, the search engines, and whatnot. So if you can notice, right, these use cases are not majorly related to RAG itself. These are typical AI use cases. But what RAG would do is RAG would increase the accuracy and overall quality of the output, which we get from the LLMs. So that's why we use RAG in the AI-based applications. Now let's jump into how to design a system using RAG uh, in the while creating the AI applications, right? Um, so here at Cloudera, we majorly use Cloudera machine learning in creating the RAG-based applications. So in so this slide is basically in context of Cloudera machine learning applications. In the ingestion process, so let's talk about the ingestion first, because we have to prepare the data to feed into the generative model, and then we have to generate the AI response based on that data, right? So during ingestion, we first gather the data from various data sources, and then we flow that data into the data processing pipeline. In the data processing phase, we do the things like chunking, and then we generate the embeddings from that chunk data set to store into the vector database. Here I have used vector database, but we can also leverage the document database or document storage, just like I mentioned, like S3. Um, and then in the retrieval phase of the RAG, user can interact to a web-based application, which can be also hosted inside the CML, and it can perform a vector search on the vector DB. And then the relevant contents which are fetched from the vector database can be sent to the LLM to generate the relevant response, right? And that relevant response can be sent to the end user. So this is how the design of typical rack system looks like if we are going to design it using Cloudera machine learning. Okay, so now let's go one level deeper on each of the building blocks of the RAG. So first of all, while doing the ETL, there are some nuances which we need to take care uh, when we are doing the ingestion of the documents from various data sources. Since the data can be of big in nature, like it can be it can be of bigger size, we need to perform chunking to synthesize it into a manageable chunks. Why we need to do that? Because it will enable the embedding model to handle the input in a way so that we can generate the embeddings from it and store into the vector database. Now, what are the benefits of it? The primary benefit of generating the chunks from the larger data set is it will improve the search accuracy overall. Because if we are going to search into the vector database with the chunked data, we are going to hit only that chunk which is having the relevant information, and that will improve the search accuracy overall, right? What next? Other than improving the search accuracy, it will also improve the performance of search, right? Because we are going to consult only those clusters in the vector database which are having the relevant information. With that, we are going to improve the search performance as well. And these are some of the methods using that we can do chunking. The trivial one is fixed length, which is obviously, as you know, you are going to use the embedding model, and you are very aware of it that what is the input token limit of your chunking model or the embedding model. Using that, we decide how to perform the fixed length chunking. A specific variation of fixed length chunking is the overlapping. In that, we define what percentage of data can be overlapped to generate the chunks so that the chunks are correlated with each other and those are getting stored in a more semantic manner, right? And then last but not least, we have a context-based chunking where we use the model or LLM to determine the context of each chunk first and then generate the embeddings using that context and then store it into vector database. So these are some of the methods of chunking. And since now we have generated the chunks, now it's time to generate the embeddings of those chunks. Okay, so for embedding generation, we have to use the embedding models. Fortunately, there is a MTab leaderboard on the Hugging Face. We can consult that MTab leaderboard to determine what is the best suited embedding model for the use case which we are tackling while creating the RAG-based applications. So here is the preference. We should use the in-process embedding models rather than some pre-hosted ones. Why? Because it will minimize the network I/O gradually as well as drastically. Because whenever we are using the local embedding model, which is hosted inside the same process, it will not, result the traveling of the embeddings over the wire, and it will just generate the embeddings and store into the vector database. So the providers like OpenAI as well as the Cohere, those kind of providers which are providing the embedding models, which are hosted in nature, if we are leveraging it, one downside of it will result into higher network I/O, right? And then some of the parameters which we need to consider while uh, selecting the embedding models from the MTab leaderboard. One of them is it should have high recall value. By recall value, I mean we need to, the embedding model should return more relevant results out of total results, whatever it is fetching from the database. So it's kind of a ratio. of uh, relevant results over the total results, and the higher dimensional value. So why higher dimensional output of vector DB? Because the more dimensions would be, it will translate into more precise information from the text into vector-based embeddings. Um, and the most efficient memory footprint based embedding models would be preferred, because ultimately these are going to be hosted into our in-process systems, where we have a limited set of GPU DRAM, right? We need to determine what is the DRAM size of the GPU which we are using, and based on that, we need to decide what's the memory footprint of the embedding model which we are going to use. Um, the open source license is preferable, because ultimately we are going to create the solution for some consumption. And if we are having some restrictions in the licensing model of the embedding model, then it's not going to work in ultimate distribution of the software. Um, and last but not least, the model files which are there into the Hugging Face, or let's say OLAMA, those should be in safe tensors format. By safe tensors, I mean they are free from remote code execution, and they will be most likely not hit by any vulnerabilities while we are using them for generating the embeddings, right? Um, so these are the some tips or some prerequisites while selecting the embedding models. Now we have generated the embeddings, right? Now it's time to store them. For storing the embeddings, we are using the vector database. So here are the list of vector database based on their pricing format. We can use any of them based on our use cases. So now the data is stored into the vector DB. It's time to fetch them based on the relevancy. Here is the methodology which comes in place, which is called as approximate nearest neighbor search, right? We have got three algorithms from it: uh, Euclidean or L2 distance, inner product, and cosine similarity. So there is no zero-shot way to determine which one is which one fits in which use case. We need to experiment a little bit with the data set we have stored in the vector DB, in order to determine what use case, what algorithm is best suited to fetch the relevant result sets from the vector DB. And obviously, we are talking about vector database. Just like another database, we need to create the indexes to get most performance out of it while fetching the data, right? So So now we have fetched the results from the vector DB, or I should say the most relevant results from the vector DB. Now it's time to talk about the G of RAG, which is generation. Now we have to generate the data or output from the generative model. We have got the most relevant results. Now we have to put those most relevant results into the prompt in a manner so that we can clearly tell the generative model, here is the instruction, use those instructions and the input context to generate the output of the input query which the user might have asked, right? So using that, we are going to generate the hallucination-free output, at least, from the vector DB as well as from the generative model. All right. So so far we have seen the building blocks of the RAG. Now it's time to uh, go through the demo. For demo, I would like to show you the Cloudera's machine learning platform. Uh, Here I have listed couple of workspaces. As you can see, these workspaces are created on public cloud environment. We can create the workspaces on private cloud as well. So if I go inside the workspace which I created, I can see the list of projects in here. So workspaces are nothing but the group of projects which can be used to create the RAG solutions, right? If I go inside the project, I would see uh, this kind of screen where I can see the code base. On the left, we have a navigation options. I can go to the jobs. Here I have created a couple of jobs to ingest the data from the Cloudera KB articles into the vector database. So for this demo, I have used 10 KB articles uh, to fetch from Cloudera's KB platform into the vector database. And let me try to query those 10 KBs real quick. As you can see, we have these 10 KBs. I would copy one of them, just like let's take this example. So this is the search app, by the way, for RAG. So if I would enter any query into this search application, it will try to consult the data which is stored into the vector DB. It will show the relevant results on the bottom. And right now it's trying to generate the AI response from the most relevant information which is found from the vector DB, right? Here, as you can see in the top, we are showing the relevant information or the generated response from the generative model. Here in this case, I am using GPT, but we can use Llama or Mistral for generating the AI response. Um, I can show you one more example how it works. So I'm copying this string, how to remove corrupt partitions. So it will try to fetch the related KB article first, like here, and then it will send the related KB article to the GPT to generate the AI response for the questions asked, right? So this is a typical flow of RAG. I think this demo was able to, uh, convey the idea of RAG. Now we can come to the questions if we have any. Yeah.
Hi.
Hello.
So you explained that if there's a predefined data set, we can do chunking, embedding, and then we can perform RAG on it. But is there a way, if there's a continuous source of data, can we perform a RAG on it, like live RAG, and then have a client server interaction and query it? So is there a possibility? If yes, then how?
Okay, so live data, you mean we have a live stream of data sets which are feeding in into the vector database, and we have to perform the query based on the RAG, right? That was the question, right? So this is what so this is the static data set which I showed in the demo, but we have actually the processing pipeline which I showed into the design as well. There was an ETL process, right? The ETL process is nothing but the ETL pipeline which can leverage Kafka obviously for a streaming thing. So you can continuously get these streams from the various data sources. Let's say somebody have created the new doc into the Google Doc. You want immediately to be reflected in your search query, right? So that can be done using defining the ingestion process clearly. And then as soon as that data will be available into the vector DB, the search would be able to fetch that response from the vector DB. And then once you will get the response from vector DB, the AI response can be generated, based on that.
So the key here is the ETL process. If that
Exactly.
is done correctly, and once the data is available, fetching is the normal query.
Absolutely.
Okay,
Yeah,
thanks.
sure. Okay.
Yeah. Just to add on to that question which you're answering, right? It's just an information that I'm giving. I feel the bottleneck there would be the ingestion to vector database. As far as I've worked, as long as we handle that, it should work fine. So my questions would are about context based chunking. What are you doing to get the context-based chunking? How much time will that take? That because that's not like normal programming that we do, right? That is my first question. Second one would be, which search algorithm are you using? Is it like normal search? For example, it might be a cosine similarity or normal similarity search, or is there a algorithm that is built like machine learning algorithm, nearest neighbor algorithm used there?
Okay.
Because those normal cosine similarity doesn't work that well, as we know. Next would be security and testing. How are you managing security for the models if you have your own data? And what are you doing for testing? Like not manual, but yeah, of course, testing of the model that you have built.
Sure. Yeah. Great questions. Thanks for asking. So I'll go one by one, right? So first question was, uh,
Context-based chunking.
huh?
Context-based chunking.
Yeah, yeah, sure. So first question was context-based chunking. Why to use that, right? Uh,
No, I know why to use, but how are you using it? Like, what are you implementing
okay,
to use?
sure. So context-based chunking is producing the high quality of chunks. By high quality of chunks, I mean the chunks will contain more relevant and contextual information before even generating the embeddings. So, but it has an overhead, right? You have to calculate the context before chunking, before generating the embeddings. So for that, you need to use another model
Mm.
to first grasp the context out of the chunk and then make sure that this is the final chunk which is going to be present as an input for the embedding model. So the accuracy will be increased, but with the cause of you know overhead of generating the chunks, because you will have to manage one more model to generate the relevant context from the chunks and then combine the chunks together to generate the final embeddings.
Yeah.
Does that answer?
Yeah, yeah.
Okay.
Just an additional thing is,
Yeah.
are you using the same model for that also, or are you using something, some other model?
Right now, since since this is correlated with the ingestion process, so the having the additional model as well as generating the context-based chunks, right, will involve the latency into the ingestion process or the data incoming, which is passing through the ETL pipeline. So for that, we are calculating the chunks using the fixed length method with some overlapping, so that the chunks which we are calculating can be related with the previous chunks in a way with the overlap, right? Whatever the text is getting generated, it is having some overlaps with the previous chunk as well. So we are using that method instead of this.
That's good.
Okay.
About search algorithm.
Sorry.
Search algorithm. Which search
Okay.
algorithm?
Search algorithm is ANN, as I mentioned. We are using the inner product based context. Yeah.
Okay. Security and testing.
Security and testing, right? Okay, so for security, as I mentioned, we are taking the necessary precautions of using the LLMs, which are having safe tensors files, and those are pickle free. By the way, in the Hugging Face or any other LLM management or LLM code base like Olama, you will clearly see that they are listing now that this library is having pickle. So clearly you can determine that you don't have to use these LLMs which are having pickle in them. And safe tensors is de facto, standard to use the LLMs which are free from remote code execution or any arbitrary code execution for that matter.
That is good. Additional question to security is, how are you handling the security concerns that arise from the hallucination?
Hallucination, right?
Yeah.
So that's why the RAG. So in the prompt, we clearly mention that this is the context which the generative model has to consult while generating the response. Because, and we have provided the clear instructions in the prompt itself that it does not have to, overestimate anything or assume anything while generating the answer.
Yeah, that usually even with temperature zero and using React as well for it to think, still it hallucinates sometimes,
So,
and yet,
okay, yeah, still so for us it does not, because the temperature is, we are not playing around with any temperatures or any other parameters in this case because we are using GPT. But in the prompt itself, we have clearly mentioned the instructions. That's why in one of the slide with where I was mentioning about AI response generation, the clearly mentioned and very crisp instructions to the generative model is very important. And also it should not excuse the input token limit so that the, context should not be lost.
Okay, that's good. About testing, how are you testing the model right now?
So for
Like the whole
testing,
system.
whole system, okay. A great question. So we have created the test suites, which take the input from various users. Sam is helping us to get the various questions for the system, and then we run those test suites with the clear references of the source of truth, and we compare those source of truth with the first few result sets which we are extracting from the database, to determine how accurate our system is.
Okay. Are you using any framework or is it done like manually?
It's the manual software. It's not framework. Yeah.
Ah, cool. I'm good with it.
Sure. Thanks. Great questions. Any other questions? Oh,
Cool.
okay. Cool. Thanks.
Thank you so much, Umesh. It was a great
Thanks, Sam.
presentation, and I
Yeah.
liked all the questions.
Thank you.
Hey everyone. Sorry, I'm not used to talking in a mic, so apologies. So I'm Arvind. I'm a software engineer at DigitalOcean. I've been working with DigitalOcean for about a year. I joined October of last year, and I work with the storage team. Specifically, I work on the block storage devices that you see at DO. So just a brief overview of what we are going to talk about today. So we are going to talk about GPU droplets. But before we dive into that, I'd like to introduce you uh, to a droplet. So how many of you here have actually used DigitalOcean, spun up a droplet in the past? Raise your hands. So very few. So I think this will be helpful. So a droplet is basically a virtual private server that runs on DigitalOcean's platform. And the main advantages of a droplet over other hyperscalers are that it's very simple to use, it's very simple to spin up, and it's very simple to reconfigure, and it's very simple to uh, make it globally available. But instead of just talking about it, let me show you a very quick demo on how easy it is to actually spin up a droplet. So if you log into your DigitalOcean Cloud Console, it's as easy as clicking create and droplet. And this is spoiler for today's talk, which is GPU droplets. You click on a droplet and you specify your configuration and the region. And as you can see, we are available globally in multiple different data centers. And you choose your image. We have a bunch of Linux distros available. You choose your CPU, you choose your RAM, and you add extra storage if you need. This is what I personally work on. And just a note, you can add up to 16 terabytes of highly available and persistent NVMe SSDs to your droplet. And you create an SSH key, which is pretty recommended, and you click create droplet. It's as simple as that. And that simplicity is the heart at the heart of DigitalOcean. We really care about it because we primarily cater to small to medium businesses and startups. So let's go on to GPU droplets. Why and what are GPU droplets? So even with all the advantages of droplets, one thing that droplets doesn't have, which is very crucial to AI and ML workloads, is a GPU. So we have recently introduced GPU droplets, which are powered by NVIDIA H100 GPUs, and it comes in two formats. You can either get it with a single GPU, or you can get it with 8 GPUs bundled. And even if that's not enough for you, you can add on multi-node configurations and spin up a lot of droplets, and you can have multi-node configuration that utilizes a lot more GPUs and a lot more power along with it. And these are the specs of the GPU droplets that we offer right now. And currently it's available in two regions, Toronto and New York. And as you can see, the NVIDIA H100 GPU comes with 80 gigs of memory and 240 gigs of droplet memory on top of that, and a boot disk and storage disk of 720 gigabytes and 5 terabytes, and a transfer of 15,000 gigabytes, which approximately translates to about 16 terabytes. And that's the free allowed transfer before we start charging you for it. And the good thing about Droplets, why DigitalOcean Droplets over anything else, right? As I showed you, first of all, it's very simple to spin up, very easy to configure. And the billing, we actually bill at a granularity of per second, not per minute, not per hour. We charge you per second of usage with a minimum usage of 5 minutes. And along with Droplets, DigitalOcean has a lot of other products which can enhance your system. Namely, if you need load balancers, we have managed load balancers. And you need additional storage, you have volumes through which you can add up to 16 terabytes of storage, very highly available and persistent. And if you need managed Kubernetes, we have that. Managed databases, you have that. And the best thing is they all work seamlessly with the GPU droplets. And recently, along with GPU droplets, is something we are very proud to announce, is one-click models with Hugging Face. For those who are not familiar with Hugging Face is a platform, it's a community for AI developers to share models, data sets, talk to each other, and fine-tune their models. So if you look at this is a list of one-click models through Hugging Face that we have available at DigitalOcean. And the best thing about this is the models are maintained by Hugging Face so that you don't have to worry about maintaining them. You don't have to worry about the stability of them. You can start developing and playing around very quickly in minutes, not days, not hours. And some of the advantages we have for the Hugging Face one-click models is that we have optimized it end to end, and you don't have to worry about it because it's all abstracted behind DigitalOcean's infrastructure. And the fact that you can start playing around within minutes, which is very important because especially for startups and small businesses, we don't have the infrastructure or the manpower or the resources that enterprises do so that they can pay hyperscalers and set up the infrastructure there. So we try to abstract it so that it becomes easier for you uh, to, to test your models, to deploy them, to fine tune them, etc. And as I said, the models are maintained by Hugging Face so that you can have access to truly optimized and fully tested models. And why DigitalOcean? Like I said before, simplicity is at the heart of DigitalOcean. And the GP Droplets is just another addition of products to our already existing suite of great products. And the fact that it seamlessly works with everything else means that if you had an idea that you wanted to test it out, and you chose to go with GPU droplets, you can spin up a droplet, you can play around, you can fine tune it, and you can test it in a day. You don't have to wait a few days. You don't have to hire resource. You don't have to hire people. You don't need extra resources just to configure the pipelines. And if you'd like to sign up and try DigitalOcean droplets, GPU droplets, that's a QR. You can check it out. I can come back to it later if you need. And I'd like to take a moment to talk about this whole first part seemed like a big advert for DigitalOcean, but why is that? And what does the future hold? At least what I think it holds for AI cloud, and what we need to keep doing, what we need to improve, what we need to stop, and why am I talking about this? So first of all, most of the hyperscalers that give you access to GPUs, that give you access to train and inference your AI ML workloads, they all they don't focus on small to medium businesses or startups. They are fine-tuned for enterprises. So you need resources to configure. They give you more raw power, of course. But what we are seeing today in the AI space, especially in the generative AI space, is that a lot of new startups are coming up with a lot of new ideas. For example, I talked to a friend last week, and he's doing an AI-based startup in a construction workspace. And just to set up that complicated pipeline, he would need months, right? Months to do that. And who has that kind of time or resources? What we need to do as cloud devs is simplify the setup of infrastructure so that people can test their ideas and validate their ideas quickly, cost effectively, easily. That's what accessibility means. And that's how we can improve the knowledge that we have and the sharing that we have. Because let's face it, I'm not working on developing models. I'm not working on large data sets to train those models. People way smarter than me are doing that. So I'm just here and I'm working in a team that's helping them realize and validate their ideas faster. That's also another way that we can help. And another thing that future holds for us is we have a generative AI platform coming up, and this is really, really cool. So you can see the products at the bottom, what we already talked about. What's at the top is that we have a fully managed generative AI system to spin up. For example, you can spin up a chatbot in under a minute, and you can use RAG-based pipelines, the one Umesh talked about before, very seamlessly. You have a document, you upload it to DigitalOcean, you have a chatbot in a couple minutes. These are a few things that we have planned that is coming up. And as you can see, to the second point, Umesh already went in depth about RAG, so I won't go there. But the fact that if you think about it right now, how hard is it to have a document, a list of documents, a list of data sets, and to create a RAG-based AI chatbot with it? Right now, with the solutions that we have, it's pretty hard. But that's what we are trying to do. We are trying to simplify and streamline the process so that you can benefit from it. And if you want to test out the early access of our generative AI platform, that's right there. That's about it. It was a pretty short presentation, but if you have any questions related, unrelated, I'm happy to answer. Yes?
Thanks. I have three questions actually. First one is that you showed that you have two offerings with one H100 and with 8 H100. So how does that 8 H100 communicate with each other internally? You may not have the answer to this, but just out of curiosity.
I sort of have an answer to that, but so the thing is, when we have our data center set up in such a way that the 8 H100s are interconnected physically, not through software, not virtually, physically. But if you want to go above 8 GPUs, that's when you need to use multi-node preferences. And you can contact our sales team for that. They'll get you set up with a very good price at a very quickly. And what happens then is we connect multiple systems together, and that may be not as uh, not as fast as having it in a singular system like we have the 8 GPU setup.
Okay, fine. Thank you. Another question is there any way you check for analytics, metrics, observability?
Yes. So as I said, DigitalOcean has a lot of products that can enhance your overall system along with the droplet. So one of them, we have something for monitoring and alerts. Not sure what the name is on the top of my head, but it gives you a full log-based system and metric system and alert system all together.
So it's for CPUs or GPUs included?
It works independently of what sort of droplet you're using. So even in CPU-based droplets, we have two more configurations, which is memory optimized and CPU optimized. So if you have memory intensive workloads that you need more RAM for, but you don't really care about the CPU, you can choose one. And if you want CPU performance, you can choose that. Or GPU, you can choose GPU droplets. But that doesn't really matter in regards with the other products that we have. You can interconnect them seamlessly.
So basically, GPU, we can check the observabilities of GPU devices.
Yes.
That is okay.
Yes.
And the last one was that you said the models are maintained by Hugging Face, but once we install, after installation, how is the maintenance taken care? Like it would be installed in a VSI or droplet for this matter. So how does that maintain after installation?
Uh, so are you asking about the updates to the model?
Updates, yeah.
So what happens is once you install it and set it up in your system, it's sort of you cannot update it while it's online, right? But there are ways. So we have something called snapshots in DigitalOcean, where you can take a literal backup of the current exact data that you have, and with that you can update your model. You can use a previously snapshotted image, and there are ways to update the model, but the model update isn't automated, if that's what you're asking.
Okay. Thank you so much.
Yeah, hi. You talked about creating AI agents. So agentic AI is picking up speed these days. Can you speak
Sorry,
more?
can you repeat that?
Yeah, you briefly mentioned about AI agents, right? So can you talk how you can create a AI agent using DigitalOcean?
Sure. Unfortunately, I don't have access to the platform right now in my current account, but I can tell you how. So, as you saw how I created a droplet, it's very similar to that, except you have a different set of inputs. And one of the inputs is where you can upload a data set in the form of PDFs or in the form of anything else, generally. And it's as simple as uploading the PDF and clicking the button, and you have a chatbot window right there, and you can start asking questions as soon as it's set up, which it just takes a few minutes. And right now we have early access to that. If you want to check that out, you have to sign up for that though, and it will be rolling out soon, and we will be adding a lot more features to it later.
Thank you.
With respect to the droplet specs which you showed in the previous screen, right? So basically the like I see the more data centers coming soon. So are they with the same set of AI accelerators with NVIDIA, or you're going to use this competitors AI accelerators as well, like from AMD
Uh,
and Intel?
so as of right now, we're using NVIDIA H100s,
Okay.
and because it is currently class of the art, one of the most powerful GPUs for AI ML workload training,
Okay.
I cannot definitively answer you that we have other models coming up, but the reason we chose NVIDIA H100s is because it will be widely applicable to even to startups and SMBs for large model trainings with large, really big data sets.
Okay.
Right. It's valid for them. And that's why we have two configurations. You can either get it with a single GPU or with 8. As far as I know, we have other regions coming up, but not with other GPUs as of yet.
Okay. Yeah. Thank you.
Hello everyone, good morning, and hi everyone. So I just have one small doubt. This is regarding the one-click models that you have explained. So wherein what you have said is that we have the list of models based on our requirement. We can use one model and we can get our work done. So let's say I have a data which is of integrity critical and I'm uploading into that model. How do I ensure privacy and security of the data that I'm currently giving to it? So what are the measures that are being taken by whatever the developers who are building it, so that whatever the data that is being added to it, once the work is done, let's say if it is integrity critical, once the work is delivered, once my job is done, it should not be there right over there. So what are the measures that are being taken in terms of privacy and security? Can you please elaborate on that?
Sure. I'm not sure I can answer your question fully, but I'll try. So first off, the thing you see with one-click integration with Hugging Face, you should not think of it as a separately entirely new thing that's coming up. It's basically a GPU droplet. But the thing is, we're making it really easy for you to set up the base image and the base system for you to test your stuff on. So what the one-click model does is just it has pre-installed GPU drivers, it has the model setup, and it has it optimized through our link with Hugging Face. The security part is entirely separate. What I say about security will apply not just to this, but to all of DO. So we have a dedicated security team, and they have been working overdrive, like as I've seen as from the time I joined, and they. I know I'm not directly answering your question, but I'll get to that. So they go from checking every PR, and they frequently identify even minor of the minor issues to regarding privacy leakage and third-party attacks and everything. And I'm very confident in saying that we have one of the best security teams. And regarding privacy, what you mentioned, the data that you store within your droplets, that is private completely to you, uh, and we cannot see it, and we try to prevent third party from attacking it and seeing it. That's the best answer I can give you.
Works.
One more, like basically the H100 which you're using, right? So it has 8 GPU cards which you made, right? So, like, what is the model bring up time? One first question is, what is the model bring up time for the 70 billion parameter which you showed?
Sorry, what is the model?
Bring up time for the 70 billion parameter which you
Bring up time.
Yes, yeah, bring up time. And like if in case if you want to scale up for the more number of like 70 billion parameter model, say from Meta, then like how does the time it takes and how many of this replicas should be needed for H100 hyperscale like AI accelerators?
So the time to set up, if you want the standard 8 GPU model setup, it's very less. You can set it up in a few minutes to an hour on a good day. When there's not a lot of traffic, you can get it done very, very fast.
What
You'll
is the
see it
time?
before you finish a cup of coffee. Huh?
What is the time? Like how much time it takes?
I cannot give you a definitive time answer, but it ranges from a few minutes to less than an hour for the system to get up and running. If you do need multi-node setup, like you mentioned, like more than 8 GPUs, then that's basically having multiple 8 GPU systems interconnected. So you can either do that yourself or you can contact the team to do it for you. In which case, it might take a little bit of time for the communication. But system-wise, it takes a few minutes to an hour for a system to be up, and then you're good to go.
So it's using any like K8s as such architecture to scale it up and down, or behind that?
K8s, we have a separate managed Kubernetes service that you can use along with your GPU droplet.
Okay.
If you want managed Kubernetes, or if you want to install it yourself, you're very free to do so. And
Okay.
but yeah, you know the complexities that come with installing and managing a Kubernetes cluster.
Yeah. Okay, thank you. Regarding the security, right? I just wanted to know, is it hosted locally, like the model that we deploy, right? One click. Is it hosted locally or how is it? I mean,
It is hosted totally on DigitalOcean. So the one-click models that you see is just for the setup. So Hugging Face hosts open source models. None of them are closed source that we have to rely on a third party to, host your data or your model or anything like that. It's completely open source so that you can import it and host it within our DO infrastructure.
I guess that would answer your question, I guess. If it is hosted locally, then I don't think there is a security concern. If we want to consider security there, we would have to just check the model
If that
as in
was
open source.
If that was your question, I'm sorry for not understanding it, first
Right?
of all.
If
But
I'm
yeah,
right.
the data is completely independent within our DO infrastructure. So you don't have to worry about it being leaked or being accessible for a third party.
That was your question, right?
So basically, I'm new to AI. So this is the first time that
Same here.
I'm just trying to get the sense of it. I come from a oil and gas background. So when I try to make sense of it, what we are saying is that there is a model. We are just feeding in the data, and it is providing the output that we really require. And if we have any questions related to the data that we have provided, it will answer us. And that's very simple. It's simplifying the process. It's very clear. That's how the whole thing works. And regarding the GPUs that you have explained, we are having a huge machine out there, and we are using partial, probably I would say, a portion of it to execute our tasks. That's what essentially GPUs are. So when we are when there are so many tasks that are happening in, if we want to execute our task which is of high priority and highly critical and have a very huge critical data with us, so when you said one click model which is a portion of the huge machine, so if you are trying to work with it, how are we gonna, you know, ensure the criticality, ensure the security? That's my major concern. Not
Okay.
only for not only for this model, for any model out there. What are some security measures that are being taken? We build the model, that's fine. So whatever the data that we are giving in, whether it's protected, and whatever the output that we are getting, whether it's ethical and it's the integrity is maintained for that as well. So how are we going to ensure that? I'm just a bit
Yeah,
confused.
so regarding security, we have the standard state-of-the-art security that you see with any enterprise cloud platform.
Okay.
The one-click model is, I want you to see it just in the setup phase. Once you set up your machine, once you do the click and you have your system set up, you can forget it's a one-click model setup. You can treat it just like any other system, any other normal droplet or a GPU droplet. So security in terms of one-click models doesn't change, is what I'm saying. The one-click is just for the simplicity of integration, and since it's coming from Hugging Face, who I believe are very good at what they do. It's optimized and it's secure at the time of the setup, if that makes sense.
Okay.
The answer would be something like there are levels of security which you're talking about. First one would be if you have GPUs present, like if you have a huge machine and we are using a part of it as a GPU, then the first security concern would be about cross sharing, which they should take by default whenever they are buying GPUs. It's not up to cloud latest like is what I feel. That's first thing. Second thing is about network security, which you're talking about. So whenever you say that we are using GPUs, that means we are sending data or we are using it. So network security would be taken care of by default using TLS or MTLS, any kind of security protocols. That's normal internet security. And the third one would be about your model security, which you are hosting by giving critical data. That would be taken care of by the people who have built the models, not by the cloudlet hosting platform. Platform will just like allow you to host the model by keeping the cloudlet secure from other attack people who attack outside using firewalls and much more to that. But regarding the model, it should be done by the people who have built it, like who have reviewed the PRs, who have done testing on that, those things. So I
And to
hope.
add to that, since we are using open source models for the one-click integration, there is a lot of you can already go online and look up how secure it is. It's not closed behind a wall. You can look at the code, you can look at how it was created. So you know exactly how secure it is. And also another thing that security depends on is how you expose your system. How you use your system, if you're exposing it outside, for a demo, for whatever reason, how you are doing it, that also adds to the security. But DigitalOcean, we do our best in terms of protecting your system and your host.
Okay, start.
I mean, like, is this the only GPU available with DigitalOcean? Like, do you?
Yes, currently yes, and as much as I know, uh, no new GPUs coming up
I
anytime
mean,
soon.
these are or all the very like higher side of like a GPU, like this.
That is true. That is true. That's why one of the things. So at our scale, we are majorly serving, like I said, small to medium businesses and startups. So we don't have the. We wanted to test it out with a single setup first, and we give uh, two configurations. But I realized that H100 is still a very powerful and overkill for many of the use cases. But we wanted to choose a GPU that can attract and be useful for a wider set of audience. So right now, the H100 is it. But if there is a lot of demand, maybe we can bring in A100 later down the line. But don't take my word for it.
Or like virtual splitting of this like GPUs.
Oh, you mean the cost?
I mean virtual splitting of this GPUs like in for like smaller plans. Like I mean this might be again high on the very higher plan like monthly wise.
That is the
again,
smallest plan we have right now for GPU droplets, which is the singular H100 GPUs.
Okay.
Thank you so much, Arvind. It was a nice discussion and good presentation. Thank you so much.
Thank you for bearing with me, everyone.
Morning, everyone. This is a little bit about me, and you might be wondering about what is a platform engineer doing in an AI meetup, right? So before starting off with that, I want to set the premise for today's talk. It's going to be about virtual clusters. And someone just asked the question earlier about how do you slice up, virtualize, or share the resources, because H100 probably might be too much for you. Probably some part of that question, I think, and I can answer using virtual clusters as well, right? So I'll come back to that question later as well. So who am I? I'm Prakash Mishra. So I am a senior platform engineer at DigitalOcean. So I don't work on anything that you will be using with DigitalOcean, but my customers are my internal developers, and I work on building an internal platform which the rest of DigitalOcean uses to deploy their services and code into production, right? So that's a little bit about me. And just to set a little bit of premise, usually when you do a conference talk, you're not allowed to talk about competitors. But today I am going to be talking a little bit about, the inspiration for this talk. How many of you know this company, CoreWeave? Have you come across this company called CoreWeave? Mistral. Mistral, we all know Mistral, right? So Mistral used CoreWeave infrastructure to train their models, right? So CoreWeave is also a infrastructure provider. They provide GPUs and bare metal, servers. So yeah, I was just going through that, and I came across this KubeCon talk on how we power the largest AI deployments on the planet using virtual clusters, right? So this KubeCon talk is there on YouTube in case you want to go after this talk and watch it. It's a very interesting talk. And my talk will be delving a little bit towards how can you, so there's a famous saying that goes, right? A penny saved is a penny earned, right? So every bit of optimization and like every bit of resource that you can optimize and efficiently use in your infrastructure is gonna give you an advantage over your competitors as well, because the cost saved will be like, extra resources that you can invest into something else, right? So vClusters as a technology, I'm very excited about as a platform engineer. And also for most of us over here, we can take, so what CoreWeave did for external customers, their customers are like, startups and like enterprises as well. They have some enterprises on them. And what they did for their customers, a couple of us or we as platform engineers can take into our own companies and do it for our internal customers, right? Pretty much their customers are external facing, our customers are internal facing. So my customers are my developers, right? So you can take inspiration from what they do and implement it at your own companies as well, right? So I'm just going to take some inspiration from this talk and try to do justice to this AI theme of this meetup. So yeah, for those of you who prefer to read, here's the blog. You can read it on their website as well. It just talks about their decisions and why they decided to use a technology like vCluster, right? So before starting with the talk, I want to do an elevator pitch, right? Remember back in the day, I don't know how many of us were alive and working back at that part where all the servers that you used to get were bare metal, right? You had to buy a server, either run it yourself or go to a provider and they would give you a server, and then you log into it, and then the performance was great, but it wasn't great for when the workloads were not being used as much, when the traffic was low and stuff like that. So what virtualization did to bare metal is what vCluster can do to your Kubernetes. So how many of you here run Kubernetes today? I do. I think a lot of us do, right? So what virtual clusters are to Kubernetes were what virtual machines were to bare metal. It is a way of chunking a large infrastructure that you have into smaller pieces, each independent from each other, where the users of each of these systems, like if you were to access a virtual machine today, you will not know you will not be affected by anybody else, right? It is your own isolated environment where you can do your work. And so what virtual machines were to bare metal servers, is what virtual clusters are to Kubernetes, right? So you can run isolated environments independent of each other, give it to your developers, they will be happy, and you will be happy as a platform operator, an infrastructure engineer, where you don't have to deal with the complexity of like chunking these resources up for them, right? Or giving them a shared Kubernetes cluster, right? So yeah, I'm just gonna try to introduce vCluster. If we have time, I will do a short, quick live demo, right? Where I will show you how easy it is to chunk up your Kubernetes clusters into vClusters, right? So just gonna talk about a little bit about the implementation details. I'm sure the engineers here would be itching to know how this cluster is being achieved. So imagine if you could run your Kubernetes cluster in a pod, right? What vCluster essentially does is runs your API server and a bunch of controllers inside of a pod, right? And you talk to this pod. This pod is your cluster. You give your developers access to this pod through ingress or whatever, and they talk to this pod, and this pod has the API server, and your cluster is entirely inside of this pod, right? But it does a few things to achieve that whole view of a cluster. So ideally, for a developer to use vCluster, he will not be able to tell you if he's using a virtual cluster or a real cluster because everything is the same. All the manifests that he uses, the developers don't have to make any changes to their workflows to use a vCluster, right? To them, they would not be able to say if this is a virtual cluster or a real cluster. It just is the same. They can create namespaces, they can create deployments, stateful sets, whatever it is. What is happening is there is this one component mentioned down here. I don't know if you can see that. There's a syncer, right? So how it works is every time I go ahead and create a deployment in a virtual cluster, it goes to the API server, stores the deployment control, right? Hello. Yeah. The deployment controller kicks in, creates the pods that are necessary for this deployment, right? But what happens when the pods are created? The virtual cluster is virtual. It does not really exist. It exists inside of a pod. So this component called syncer, which is here, which sits right in between, is listening for these events that, oh, a pod got created. Oh, a config map got created, right? And what it does is it syncs all of these objects onto the parent cluster, the host cluster, right? So it creates a mapping. It creates a mapping of the name, right? Pod X hyphen namespace X inside of the inside of the virtual cluster, and it creates that mapping and manages that mapping. So whatever lifecycle events are happening with the pod, where the pod crashes, if there is an image pull back off, a crash loop back off, all of it is synced back to the API server inside of the virtual cluster, right? So inside of the virtual cluster, whoever is using it, right, gets the feel that they are using an entire full-fledged cluster, right? But outside of the virtual cluster, it's being run on the host cluster, right? The resources are actually being spun up on the host cluster, and it's intelligently being synced from the host cluster to the virtual cluster, right? Why would I want something like this as a platform engineer? Probably as a developer, you're like, all of us love when there is no restriction, right? I love it when I can just get a Kubernetes cluster all for myself and deploy my application. But it is a nightmare for platform engineers or DevOps or SRE, whatever you call them at your organization. There are two ways that people go about it today, right? Either give every developer a separate namespace on a shared cluster and hope that one of them does not go ahead and update or downgrade a component or break a component, a shared component, where it breaks the cluster for everybody else, right? It becomes very difficult when everyone's using a shared cluster with separate namespaces, right? Where one of them might make change to a certain component, which breaks it for everybody else, right? And the other approach today is to give every developer their own cluster, right? Very neat. Every developer gets their own cluster. They play around with it. Nothing breaks, right? But now the problem is of cost. I created a cluster and everyone has their clusters. They forgot to turn it off when they were not using it. And now my costs have skyrocketed, right? So both the ways cut you in different ways, right? Virtual cluster sits somewhere in the middle where every developer gets their own cluster, right? They get the full-fledged, they are cluster admin inside of their own cluster, and they get to interact, do whatever they want with this cluster. But at the same time, you as a platform engineer don't have to spin one cluster for everyone, right? As soon as someone requests you, you create a virtual cluster, takes about a minute of spin up time, and you give it to your developer, you give them the kube config, they are happy, you are happy, right? And through this, you can optimize your costs as well, right? Because now everyone's using shared resources, which I'll get to much later in the talk, right? So yes, and also virtual clusters help you where you have a need for ephemeral environments like CI/CD use cases, where you want a Kubernetes cluster, but you only want it for a short period of time. You don't care what happens with the objects once it's cleaned up, right? So during CI/CD workloads as well, a lot of places where I've seen people try to run Docker and in the CI/CD and inside of that run kind and do all of these hacks to perform their integration tests and stuff like that for their controllers and a lot of things, right? To spin up an environment, a temporary ephemeral environment. But with vClusters, you could just have a Kubernetes cluster on which you spin up a vCluster and have its persistence set to false, right? That it's not persistent and it'll disappear once you're done using it. And it's great for that use case as well, right? And then, of course, you have persistence where it persists all of the pods that you've created, namespaces that you've created onto a persistent storage. And it could be a SQLite DB, it could be etcd or whatever. It supports a lot of these data stores. And once you're done, even if you spin it down, if you kill the cluster and you bring it back up later, you will have the exact same state as you left it, right? So yeah, a little bit about the networking, but if you're not too if you're not too much into infrastructure, probably you don't care much about this part, but just going to touch on that one of the questions is, okay, there's a service inside of my vCluster. How does it resolve to the service IP of the host cluster? Because everything is going back to the host cluster, right? So every vCluster has a core DNS pod, which maintains those DNS mappings, and it points you to the right IP on the host cluster, right? So that's very simple networking basics as well, right? So bottom line, these are the stuff that we talked about. Syncer sits there, and also one more support and one more advantage of using something like vClusters is that everyone on the cluster can share resources. If you have Cert Manager installed, if you have Ingress installed, if you have Istio, if you have all of these components installed, you don't need to install all of these inside of the vCluster. You can enable syncing of these CRDs into the vCluster, and you can use a common shared set of services which you upgrade together, downgrade together, and it is common for everyone on the cluster. So I don't need to install an ingress controller. I don't need to install Cert Manager. I don't need to install all of these common shared services, right? Inside of the virtual cluster, all of this can be shared. And let's say tomorrow there's a custom resource that I have written, and I want it synced into the vCluster, right? I can do that also. So the syncer that we have also supports a way to write plugins. If I have written something custom, I can just easily write a plugin to sync that into the vCluster, and the vCluster will be able to work with those objects as well, right? So even volumes, if I want to sync from the host cluster, let's say there's certain services. Let's say I'm hosting a common useful service on the host cluster, a service that is depended on by all of the developers, right? I can expose that service, that particular service inside of the vCluster as well, so that they can all access it without having to replicate it in all of the vClusters, right? So yes, this is through plugins. I was talking about how you can write custom plugins to sync your own like operators, CRDs, and everything inside of the vCluster. And a little bit about data vCluster usage, how, you're like, how do I actually use this in production? So it has a bunch of security features as well. Isolated mode, when you run a vCluster in an isolated mode, it cannot see anything. It cannot even contact anything on the host or within other vClusters, even if it knows the direct service name, right? It cannot contact those because through network policies and quotas, these are limited. So bottom line, you can think about virtual cluster as a namespace and a pod within that namespace on the host cluster. Outside of that namespace, it cannot contact anything in the isolated mode. And also you have rootless mode where you can ensure that none of the pods within the vCluster also run with root, right? And so these are a few things. And with virtual clusters, one more advantage that you get is that when you have a situation where you have a big GPU or big GPU enabled clusters, right? You could always chunk it and say that you can set quotas that this particular developer or per cluster, this is how much max they are allowed to use. And those resource limits are enforced. This much CPU, this much RAM, and probably with GPUs as well, right? I'm sure they have a GPU story around this as well. But yeah, with your resources, you can tightly control how much resources are being used. Different teams, you can give different quotas, and they could work with those quotas and not exceed those quotas. All of those are enforced. So even if in a case, as he asked earlier, where I have a single H100 GPU or stuff like that, right? Which is way too much power for a single developer or probably even for smaller startups, right? In that case, of course, it's not just one developer working on the cluster, multiple people are working. I can chunk up their share of the H100 CPU through with each of these clusters so that each team gets a chunk and does not exist a certain CPU, memory, and resource quota, right? So yeah, just a bit of use cases. Kubernetes cluster as a multi-tenant environment where every tenant is happy that they have their own cluster and where the person providing that space, that cluster, is also happy that they don't have to manage the headache of all developers using a shared cluster and breaking things, right? It can be likened to when you live in an apartment versus when you have your own house. With vCluster, imagine a full-fledged cluster access that you get as a developer is a whole house. You can do whatever with it with very less restrictions, right? Apartment is where you have shared spaces with others, right? But it's multi-tenant, but you have your issues, right? Certain things you cannot do that you do in your own single house, right? But with vCluster, you get best of both worlds, right? I have my own full-fledged cluster, which I can do whatever I want with. But for platform engineers, it's multi-tenant. Multiple people can use it on the same cluster. And I don't have to have the headache or the cost headache as well of spinning up multiple clusters for my developers, right? And fleet of Kubernetes clusters, I can spin up like hundreds of virtual clusters within minutes. And also, if I were a developer, you're like, cool, you've given me a virtual cluster, but there's still so much there to make the developers experience better. There's still a gap to making you just throw a Kubernetes cluster at someone, the developer still has to install multiple things. You can through operators or like, I think vClusters probably might open source that feature also, but there are different ways in which you can say that when a vCluster comes up, install all of these services pre-baked into it, right? So the developer now gets a completely pre-baked environment where all of the services are running. And in one of my previous companies, we deployed our entire suite of microservices inside of a vCluster, and every developer got an entire environment by themselves, which is not being affected by others' work to work with, right? So, and if I made change to, let's say, a certain payment service or stuff like that, I could always swap that out with my own image and be working with it while having the entire environment. So you could use cluster templates as well, right? And you could use vCluster plugins to like expand that use case. And this is just some daily use case that we talked about. I'm not gonna go in detail. We have already talked about it. The use cases is when you want your Kubernetes cluster as a multi-tenant environment and creating managing a fleet of Kubernetes clusters and for your CI/CD workloads and also to extend it, right? If you've written custom controllers, which you want the CRDs to be exposed inside of the vCluster. AI-related use cases, where did CoreWeave, this company, utilize and how did they utilize it, right? So one advantage that they got is, of course, the base advantages that virtual cluster provides, where to their customers who did not have that much of a need for bare metal and everything, they went ahead, provided them with virtual Kubernetes clusters on which they very quickly iterated, built their products and trained their models and quickly brought up training clusters and stuff like that. And because all of the work was in Kubernetes, all of that work, once they went to production, could just be lifted and shifted onto a bigger Kubernetes cluster, right? They did not have to rework their workflows for moving from a simpler setup to a complex setup. Exactly the manifests, exactly the work that they had done on these small training clusters and everything could just be lifted and shifted onto a bigger Kubernetes cluster. So that's how they talk on how they used it. And they literally power massive AI workloads, right? And yes, the last point is also important, that they allow developers to cleanly and efficiently utilize shared resources, right? So when you have like multiple powerful GPUs on the cluster, but at the same time, you want everyone to share it and not hog a lot of the resources, but at the same time, not be like starved of resources. You can use virtual clusters where you set up quotas that this person or this team is allowed this much of quota, and you can share that GPU among your Kubernetes cluster users, right? And while I'm here, just preparing for the live demo, while I'm talking to you, I'll just spin up a Kubernetes cluster quickly, right? And I'll demo how easy virtual clusters are to work with, right? So hopefully by the time I'm done talking about this talk, this Kubernetes cluster is up, and hopefully the curse of a live demo does not strike me. So I am going ahead and creating a Kubernetes cluster. How many of you think this will work? In the next 2-3 minutes, this cluster will be up and we should be able to go with it. How many of you believe that it'll work? Yes, I need a little bit more belief than that. Cool. So I'm going to spin it up in Bangalore. We have a Bangalore data center. And what I'm doing right now with DigitalOcean Kubernetes service, you can replicate it with GKE, AWS, AKS, any Kubernetes cluster. You can even run virtual clusters inside of Kind. And also, for those of you who want to explore the limits of it, you can run virtual clusters inside of virtual clusters inside of virtual clusters, right? It's that simple to use. So I'm just going to use the recommended version. I'll just name it worker pool. Basic, everything I'm just going to leave it as it is. And what do we call this? Cloudera demo. Demo. I'm gonna, one second. So I'm gonna spin it up for the sake of simplicity inside of my project. So I've just changed the name of this cluster. Everything else is default. It has auto scaling enabled, and I'm gonna create the cluster, right? And this can be re-implemented for anything. Do it with GKE, do it with any hyperscaler, do it with any other Kubernetes provider. This just works, right? So yeah, coming back to the talk, the last bit of this is what was important to their customers, where their customers could come to them, work on their training, deploying, and testing out in a smaller setup. And all of that setup could just be picked and shifted to a larger cluster when needed, right? So that helped a lot with them to attract startups as customers, where these startups had smaller use cases, right? Where they did not need as much power of bare metal and GPUs attached directly to the instance, but they wanted to just get started, something to get started. And once they are done, so this helped them in maintaining the costs as well, where initially I pay much lesser, and only when I use and I have a use for such bigger GPUs, I pay for those GPUs on a larger cluster, right? And yeah, restrict the teams on what capacity and class of GPUs they can use. So you could also say that this team or this set of developers can only access the A100s or even uh, RTX or Quadro GPUs, and different classes of GPUs also you could limit them on. But of course, a company like CoreWeave are much advanced users of vCluster, right? And they made a lot of abstractions on top of it to ensure that only a certain set of developers or certain teams can access certain GPUs, and only in production you can access these GPUs. In staging, you only have access to these GPUs, right? But the last point is also important, that we can all as platform engineers and platform operators, or even startup founders who have to pay the bills for these infrastructure that our company uses, we can replicate what they did for their external customers inside of our own companies for our internal developers and teams as well, right? So that's a little bit about how you can use virtual clusters to chunk up these massive clusters which have so much of power among your developers, but at the same time keep them happy while also keeping your platform team happy, both of them happy, that they don't have to go out of their way or manage headaches, right? So that brings me to the end of it. I have linked to the talk that I took inspiration from as well. It's a KubeCon talk on how they power the largest AI deployments. Mistral uses CoreWeave, and generally this talk, I just wanted to touch upon the learnings of a large company like CoreWeave and how they utilized virtual clusters to make it easier for their customers and developers to use massive GPU infrastructure, right? So that's done. Let's see if our cluster is up. One second. Our cluster seems to have come up. One second. Give me a second. Oops, it's still coming up. Should take a few minutes more, but this is a 3-node cluster, so this was expected. But while we are at it, if you have any questions so far, I can take them. Yeah. Any questions?
Yeah, so thanks, Prakash. It was a nice discussion. We learned so much about the vClusters. So the synthesizing of the larger resource sets into, manageable and most effective pieces for developers is a great idea. And something similar we are doing in Cloudera also. We have a large, deployment of KTS. We are using CML on the top of it to, resource allocation perspective. So my question is related to similar, ideology, where we have a resource set like a virtual CPU and some sort of memory, right? We can create it as a compute unit and provide the developers. How exactly you are doing the sharing of GPUs, as you mentioned, using quotas, and what methodologies you use to share those GPUs across the developers?
Yes. So good question. So if I understood your question correctly, you have a shared Kubernetes cluster with GPUs attached, on which you give developers, each developer, a certain quota that they can use with your GPUs as well?
No. So right now we are not sharing GPUs. GPUs are isolated for the compute unit. I'm just particularly interested in understanding the way the vClusters which you are providing, how exactly they are getting shared among the developers or
Yes.
multiple users.
Got it. Just trying to find documentation on it, right?
Yeah.
But one thing that I can say, okay, let's just get back to this thing. But what I'm saying is, so virtual cluster supports everything in terms of quotas, right? Everything that a Kubernetes cluster supports, a virtual cluster supports. So it's a direct mapping. It's not doing anything above and beyond that, right? So currently, I'm not sure. I think I heard from the community talking about how they're thinking of standardizing GPU quotas, right? I'm not sure if it is currently GA yet in Kubernetes, but people are working on just like CPU quotas and memory quotas and disk quotas you have in Kubernetes. They're working on GPU quotas, right? But since GPUs are much newer into the Kubernetes.
Hello.
So I'm pretty sure that the abstraction for that will also be available soon, right? Not sure if it is available right away, right? But what I'm just saying is that you can treat virtual cluster, whatever you are doing currently on your Kubernetes, it just simplifies that a lot, right? And you can with these resource quotas, I'm sure that it will land up at least in the alpha or the beta stage in the next few releases, where you could, with the same virtual cluster, set up the quota, and all of these quotas are applied to the namespace of the virtual cluster on the host cluster. And whatever namespace quotas you today give, and as long as that supports GPU quotas onto your cluster as well. And some people have come up with custom implementations, I'm sure of it, but in the mainline, I think it can take some time to land up. But what I'm saying is the same approach that you use today with CPU and memory should be able to be mapped directly onto virtual clusters also, because it does not really, when you limit a virtual cluster to a certain amount of resources, it literally creates a quota for that namespace which the virtual cluster is running on, right, on the host cluster. So yeah, you could play around with that quota on the host cluster itself. If you increase the quotas or decrease the quotas, and whatever change in quotas that you do to that namespace of the virtual cluster on the host cluster will be reflected to that much amount of CPU and resource usage of the cluster inside of the namespace, which is the virtual cluster, right? So yes, of course, mainline, I'm not really sure exactly when it's going to land up, but looking at Kubernetes and the way it has been adopted and the way today Kubernetes is being used to deploy these AI ML workloads, I'm sure GPU quotas will at some point land up. Right now, they can all share it, but I don't think, at least in the mainline, it is generally available where you can do GPU quotas. But I'm pretty optimistic that in the next few releases, I'm sure it will land up, right? Yeah. So our cluster is up. Our cluster seems to be up. So I'm just going to download the config file, right? So I have a habit where I'm just going to put this mic up here so that you can hear me. So Cloudera. I'm just going to look for my kube config, set it. I'm just going to put it into my ZSHRC file as well, just so I'm not caught by any surprises. Cool. So now what we've done is we have created a Kubernetes cluster on DOKS, which is our DigitalOcean Kubernetes service. And I'm going to very quickly create a virtual cluster, show you how simple it is to create a virtual cluster and use it. So yes. So this is our host cluster right now, right? These are all the pods that are running. This is the Cloudera demo cluster that I just created. And these are the pods that are currently running on it, right? So now I will just go ahead and I have the commands ready. So I'll create a virtual cluster named demo inside of the namespace called demo, right? So just showing you what's happening on the, now that we go back to the host cluster, let's see what's happening. It's bringing up a stateful set. What does the stateful set have, right? It has like 4 containers, but one of them will be running. The other 3 are init containers, right? What it is ideally doing is that rather than packaging everything of that a Kubernetes version and a syncer and everything into one image, what it's saying that if you specify a certain Kubernetes version, it downloads that Kubernetes version's API server and controller manager and the necessary components. And this vCluster copy container copies them into the syncer. And this is the only running container. You have one container that's running, and this container has Kubernetes API server, the controllers, as well as the syncer running inside of it, right? So now this virtual cluster has come up running, right? So yes, so there are only 2 pods that were spun up. One is the stateful set for the pod for the virtual cluster itself. And one is the core DNS pod that I told you that manages the mappings of the service names within the virtual cluster to the host cluster. It has to resolve an IP, right? So yes. So One second. Yes. Now I am going to check the current context of my Kubernetes cluster. It has already, after I created the virtual cluster, it has exported that virtual cluster's kubeconfig locally, right? So now I'm within the virtual cluster. So this is what my virtual cluster now looks like. Right now I'm talking to a virtual cluster, which is vCluster demo, right? And how many pods does it have running? It's one pod, right? And now just to show to you that within this virtual cluster, you do not have to do anything different. Your developers will not have to do anything different than they would do on a actual Kubernetes cluster. And how it's no different, I have a ping pong setup, which I'll show you right now. So this is my Pong server. What it does is it has one container called Pong server, which listens on port 80, right? It has a service sitting right in front of it, right? Which yeah, resolves to the Pong server. And the config map is an Nginx config that says, if you receive a request on ping, respond with a Pong, right? Now I'll show you the ping client. So this is a client. It's a simple client. What it's going to do is that every 5 seconds, it is going to send a ping to the Pong. It's going to send a ping to the Pong server, right? And this is just your regular Kubernetes manifests, which I'll deploy within the virtual cluster. So kubectl apply. So now I go back to my virtual cluster. This is what's happening. Within the virtual cluster, a ping client and a Pong server are being spun up. The ping client says that, oh, initially, while the Pong server wasn't up, it says it could not connect, but right now it's receiving responses, right? And I did not have to do any changes to my workflow. These are just your regular Kubernetes deployments, right? And this is the Pong server logging all the requests that it is getting, right? And back, just one last thing to tie up the loose threads. This is how that, so I told you that the syncer manages a mapping of the pod name onto the host cluster, right? This is my host cluster Kubernetes, and this is how it has been renamed, and syncer manages the mapping so that within the cluster, you see the pod's name, but outside on the host cluster, it has been mapped to a different name. And the resources that are being used to run that pod is on the host cluster. So everyone's sharing the host cluster resources to run these pods. But inside of the virtual cluster, you do not see what's outside of the virtual cluster, right? So yeah, that's pretty much my demo there. And if you have any questions, I'm around. I think I'm already over time. So I'm around and we can talk about this more later during the break, but it was a pleasure delivering this talk for you. Thank you so much.
Thank you so much, Prakash. As we are over time, so we can address the question towards the end. You can talk to him one-on-one. I request Umesh to start with the talk. Thank you.
Joe Prakash. All the best.
Thank you. Thanks everyone for coming today. I'm Umesh. I'm from Cloudera. I've been with Cloudera for last 6+ years. I'm a principal engineer at QE and heading most of the things which happen at QE across the world, you can say, right? So quickly about me, I've been with Cloudera for 6 years and I have total of 13+ experience, and I'm Apache Atlas committer. I've been working in security and governance part for last 5 years, and now I have moved to a central team. So I'm also a chairperson of the technical review group at Cloudera. I take deal with a lot of initiatives which are of interest to Cloudera as a whole. So I've worked with Ola, VMware, Homeland, and Sapient before I have joined Cloudera. So I have a BE and MTech from PS University. Right. So digging deeper, so far the talks have been around how to get LLM working, right? So how do you solve, or Umesh talked about how do you build a rack pipeline, right? So Arvind and Prakash have talked about the intricacies, about be it about the droplets or the vClusters. Now I will be talking purely on the use cases which you can solve using generative AI. So I have been working in the quality engineering space for the last 13 years. And in the last 1 year, I have been using generative AI for most of the things we are doing at quality engineering. That the first thing, I mean, of course, you would have already read about this. AI itself will not replace jobs, but people who use AI will definitely replace people who won't. The landscape has changed in the last 1.5 years so much, and I strongly believe, I have my own reasons to believe that in the next 2 to 3 years it is going to change the way we do things. It could be a developer, it could be a QE, it could be a program management, right? So we have seen so much trends, so many improvements. In just a matter of 3 months to 6 months, there are new products coming in that is totally changing the way you do things, you have been doing things, right? So this is a famous statement by Sam Altman. When I started working about it, right? So I found it very relevant, right? So back in the days when I was doing my engineering, mobile was still, it was an idea. So when I came out, everybody started talking about mobile, right? So be it iOS development or app development, and every company wanted to be on mobile, right? So to an extent where I still remember Mintra.com, it was made completely mobile, right? So, those steps were taken, right? So, and then everyone was talking. And today, if you believe somebody is not on mobile, you will literally laugh, right? So, how can somebody not be on mobile? And Sam exactly says that in matter of few years, everybody has to be using generative AI for everything they are doing, right? So, if not, they'll 100% go out of business. The same applies to developers, QE. If you are not using generative AI, you will be out of business soon, right? So by 2027, you can see that 80% of the enterprises will have, I'm talking about QE here. The same applies for development. Maybe the penetration is already high, but I see AI penetrating in every sector, right? So my wife is in clinical research, and she was having an all hands just 3 days ago, and I was surprised to know that they were using terms like generative AI more often than we do in our job, right? And my wife is actually interested in learning about generative AI and making her job easier, right? So people from every stream are interested in generative AI these days, because generative AI can do a lot of things which you can't, I mean, throw anything at Gen AI, it can do, right? So those are few background of what generative AI can do, or what we would be losing if we are not using generative AI, right? So Cloudera as a company, we had partnered with Gartner, to do some research on how we can leverage generative AI in testing, especially, right? So if you see the current landscape, we are somewhere here, right? So it's mostly automated but human assisted, right? So gone are the days where we used to just do manual testing. So nobody does manual testing these days. At least in Cloudera, we have it in our DNA that anything which is released into production, we automate it. We have like millions of test cases running. We have different platforms, different cloud providers. We have to validate our, stack is quite advanced, right? If you see, open source is in our DNA, right? So Cloudera as a company, as a CDP, as a Cloudera data platform stack, we use a lot of open source services, and we just don't use them. We actually build them, right? So I have my friends who actually are working on building Apache Spark, Apache Kafka, Hive, HBase, HDFS. We have PMCs, committers, contributors across Cloudera, right? So we do test it, and there's no way we can do manual testing, right? So there was also a statement, right? So I think Arvind made a statement. Okay, these models are coming from open source. Imagine how secure they are, and then you can literally go and check what it is doing, right? So I like that statement because I have been working in the open source, area for last 6 years, right? So the trust you get, right? So Cloudera as a company has been partnering with open source since 2008, right? So now if you see the current landscape is somewhere we are here, and we are actually trying to move towards the right? So we do have automation, but there is human knowledge needed for building these systems, right? So what I feel, and of course the Gartner research also says, is that eventually we will move towards autonomous testing, right? So the machines will become so capable, right? So given a product, it will automatically tell you what to do, what type of test cases run, what type of mobile flows to automate, right? So we'll eventually move towards that model. So if you see the so far the testing landscape is, it's been like, a lot of cognitive overload. I'll also be talking about what is cognitive overload, right? So at the moment, if you see a stack like CDP, it involves a lot of interactions between open source products or proprietary, and it involves a lot of knowledge, right? So if some QE is testing, a lot of knowledge is needed to understanding the system and others. That is going to change with generative AI. Now AI will understand the system. The only thing the user has to know is what he wants to do. What is the end goal? You want to automate. What do you want to automate? So far, how you want to automate was needed, but eventually that's going to change, right? So with that in mind, I mean, we have been exploring a lot of use cases at Cloudera. As I said, like in the last 1 year, we have solved many problems, many interesting problems with generative AI. And first is, of course, building a chatbot, right? So there are hundreds of ways of doing it, right? So you can use different LLM providers. You can, I think Arvind also talked about how you can use digital oceans to bring a QE chatbot or a chatbot as a whole in just 2 minutes, right? Why is it needed? It is needed for complex systems to build a knowledge base. So far, if you see when somebody leaves a company, right? So the knowledge goes with them. But you build a chatbot or build a knowledge base. So any new person who is coming in, that will always help them to answer the questions, right? So building knowledge base is very important, and AI has made that possible, right? It's like you are having a mentor for you 24/7. Any questions you have, you can always ask them, right? So I strongly believe in that. And we try to build chatbots internally. We have done a lot. I think CX Genius, which Umesh also has talking, has done a lot of good things there. So most important use case I feel of generative AI is building something like this, right? So next is generating the test data, right? So we all know the industry has moved towards microservices, and there are a lot of tests, or you can say that test cases possible when it comes to testing APIs. For instance, Cloudera Manager as a service we have has close to 650 APIs, right? So imagine these are all get, post, put, delete, and different HTTP methods. And if you have to validate, it will take at least 3 to 4 months, or somebody who knows the system in and out, right? Now, what if I say that I can pick somebody from the crowd and say, okay, I'll give you the Swagger API spec, you automate this using generative AI. Trust me, you can actually use this tool to automate at least 70% of the test cases in less than 30 minutes without even knowing the service. Imagine, I'm talking about 650 APIs. If you have to do it, you will have to spend at least 1.5 to 2 months time to understand what Cloudera Manager does, how it interacts with different services in the CDP stack and others, right? So that's now gone. It's not needed. And we have done it. We have actually generated. I'll also show you the demo on how we have done it, right? So third is, of course, writing test cases and test plans that everybody is right? So any good developer, if you see, right? So if they are writing code, the first thing they have to have in their mind is what test cases we have to run on, right? So for any new system, I mean, we are talking about, again, a complex system, right? So it's not very easy to come up with exhaustive test cases. So I was talking to my friend Shantanu, he's from Cisco. He joined today, and then he was saying the exact same use case he worked in one of his hackathon, right? So, and he also won. So for them also, in order to come up with exhaustive test cases for any product, it used to take around 3 to 4 weeks. With this tool which we have built, right, and you can generate 80% of test cases which are very relevant for your product in less than 5 minutes. Imagine we are cutting down 1 month's work to just 5 to 6 minutes. We have done it. I'll show you the test cases we have generated and the quality it brings in, right? And then finally, the test code. We also have plans of generating the test code. So of course, we have things like GitHub Copilot and all, which is code assistant, which helps you write code. But the idea here is we take the automation code, identify the gaps in it, right? So when it comes to testing, the coverage is very important, right? What line coverage, code coverage, and what all customer cases are we covering? There is always a gap. There is, because you cannot do 100% testing, right? So there will always be gap. There will always be escalations. So the idea is, given a test code, given an escalation, what was the missing coverage? How do you add it? So we can actually build intelligent tools like that, right? So imagine if somebody has to do, they have to first understand the surveys, understand the code, write the test case, so finally find the gaps. Now AI will directly go to the fourth step and generate the gaps for you, right? And then fifth is, of course, the CI/CD. For any complex system, you need to have a CI/CD in place. If not, your business won't succeed. You won't be able to deliver things at scale, right? So we had worked on a hackathon project wherein we used AI. Given a GitHub PR, you, instead of, as I said, we run millions of test cases for a given component. You cannot run millions of test cases in shift left PR testing, right? So you have to run relevant testing where for a given PR, what regression it can cause, right? So you have to pick up from million test cases. How can I run only 20 test cases and that will find bugs, right? So that's very important. And then finally, another use case we find, we have been using at Cloudera is the auto triager, right? So when we run millions of test cases, at least hundreds of test cases fail, right? So now if, imagine on a day-to-day basis, you are running so many test cases, you can't spend time in going and triaging them. So what we did was we built an in-house tool called Apollo, which actually analyzes these test runs automatically. It uses LLMs and automatically tells you which peer has caused a particular test failure. Or let's say if there is a known issue, if there is a Jira already created for it, it goes ahead and then triages those run automatically. It's all automatic. After a test run happens, it takes 5 to 10 minutes. It does a post analysis and then creates Jiras. Or let's say if there is a test Jira already or a product Jira, it links that test run with that, right? It tells you exactly which PR is causing, which Jira is the root cause. So you don't have to break your head in finding the root cause. It's automatically done. Right. So chatbot, as I said, right. So I'll not go in deeper because people have already talked about it. And of course, go, you search on Google, you will get a lot of this, know how to do and other stuff. Right? So what we did at Cloudera is basically we took the wiki documents and other stuff for building this chatbot, right? And as I said, right, so we are using a RAG pipeline here. We have created, out of these wiki documents, embeddings, we created the embeddings we are using Bedrock here again, but that doesn't stop you because you can use any provider you want. Like Cloudera also has a Cloudera machine learning. You can bring your own models, deploy them. You can use GPUs, right? So for simplicity, we have used Amazon Bedrock as a use case, right? So we chunk the size, documents into smaller size, create vector embeddings using Amazon Titan, and then store that in vector database. We are using OpenSearch here, serverless vector database. And then when the user enters an input, again, that is converted into embeddings. Then we do a reverse scan search and then find that finally that context is passed, to the LLMs. And then that's how the LLM as a service will understand what context you are asking questions, right? Because these LLMs are coming from Amazon or it could be any provider. It won't have your proprietary knowledge. Right? So for that, in order to push that proprietary knowledge, you need to have a RAG pipeline, right? So that is one. There is also another way of doing things, right? So for example, the test data generation, right? So one thing, I mean, I get this question a lot from people is that, is RAG always needed? No, it's not needed. You don't need RAG all the time, right? So you can actually pass context to the LLMs without even RAG. For instance, for generating the test data, I'll show you, or test cases, we used Anthropic's Claude Sonnet 3.5, and that has a very high context window. It has 200K token size, right? So with that, what happens is, and there was also a question from somebody, right? So how do you do live RAG pipeline, right? So some data is coming on the live. I mean, how do you create RAG? So one way, of course, is you add a workflow, you generate the RAG, create vector embeddings as and when it comes, and then put it into the database. That's always possible. Second way is that delta, if it is or of any use, that delta information as a context can be directly passed to the LLMs, right? So you can write prompt engineering. Using prompt engineering, you can tell the LLM that, okay, this is the latest context. Why don't you use along with your RAG, right? So that can be done. So for generating the test cases, test data, right? So what we did was, I'll just quickly show you the Swagger API, right? So this is our Cloudera Manager Swagger UI. I'm pretty sure everybody would have seen this, right? So this is any standard Swagger UI, and then this is the JSON file powering it. And you can see there are hundreds and hundreds of lines of code, right? Imagine if you had to automate it, how long it will take, right? Now, I'll show you the test data it generated. So this is the test data which was generated by generative AI. And if I remember right, there were close to 2,935 test cases. These were generated by the LLMs, and you can see it's 2935 lines, and it was generated in less than 7.5 minutes. Compare this with somebody working on it, right? So and that's not even accurate. This we directly fed into a data-driven REST API automation framework. So I'll show you the test code as well. So if you see, we have just written 170 plus lines of code, and the data generated by the LLMs was directly fed into this. And we could run 2935 test cases in less than 2 hours, end to end total. Now, if I give somebody in this group too, you would be able to do something similar for a service which you don't even know in less than 2 hours, guaranteed. Right. So this is the outcome of it, right? So it's not like we want to, replace people. It's just that we want to make them more productive at what they are doing. Right. So next is yeah, I mean, this again, if you have to talk about it here, if you see, we are passing the Swagger API spec JSON file directly to the LLMs using some prompt engineering. And then finally, the LLMs are able to generate the data. We have CLI way of invoking these models. We have built an app which we can use, from the CLI, you can invoke so that the data is generated in whatever file format you want, right? So next is the test cases generation. So test cases generation also uses something similar. So as I said, right, so you don't need to build a rack for everything. So if you see, if you have to generate test cases, it's good if the LLM is already trained on it. For example, we have Apache projects, like we have Apache Hive Spark. Let's say somebody is trying to write test cases for Apache Spark. You can go to even Gemini or ChatGPT and ask it to write test cases for Spark. It will write, right? But imagine you have a proprietary product. If your company is coming up with something which is not open source, and let's say the LLM is not trained on it, you ask that question, it will fail to understand, and it will say, no, I don't understand. I don't, nor the context given was understanding to me. So what we do is, using models which have large context window, you can actually pass that proprietary information as context directly to the LLMs, right? For example, it could be a PDF, it could be an internal link which has that data, right? So you might be working on something which is not open source. You can pass that to the in-house models or the models on the Bedrock. So a Bedrock has this agreements. They won't train use your data to train any of their models, right? So you can pass that information, and then as a system, the LLM will generate you test cases. So I'll show you the test cases we were able to generate. So see this, there are like 6 sheets in this. We have Apache Atlas, Iceberg, Apache Kafka, Apache Knox, Ranger, and Ozone. Right? There are 6 services. These are very important services in Cloudera stack. We in fact have more than this, but I was able to generate test cases for most of the services in less than 3 minutes. Right? So if you see, let's talk about Iceberg. Right? So Iceberg is the latest fad. So if you see, we have generated non-functional test cases for Apache Iceberg. There are close to 31 test cases, and these are all LM generated. And it exactly tells me what to do, right? So it tells me the category description, what test case it is, what prerequisites are needed, what steps are needed, and what are the expected results. And it also tells me the priority. And we are now using these test cases to identify the gaps, to identify new functional test cases, non-functional test cases, to fix engineering escalations and other stuff, right? So we were able to generate test cases, and you can do it for proprietary tools, for proprietary features as well, right? So that's all possible. Yeah, so this is how we have been using, and other use cases, as I said, right? So I'm not going to much deep detail in that because it does involve a lot of internal Cloudera information. So some of them, as I said, accelerated CI testing, right? So for a given PR, we have used the code coverage reports to identify exactly what test code you have to run in order to find bugs, right? So that's one. And then the auto triager, as I said, it can use LLMs inherently to find the root causes, the failure reasons, and other stuff. And that's all I had. If you have any questions for me, I can take it now.
want to understand a little bit more on that Bitbucket PR thing, right? You mentioned that CI integration. So
Yeah.
by considering a PR, you were able to take it to the test cases and then to the closer.
Yeah.
Point number 5. Yeah.
Yeah. Let me get that. Just give me a minute.
How do I stop sharing?
Yeah. So this was a hackathon project which I worked on personally with two of my colleagues, Samada and Karthik. They are not here, but I'll be speaking about the same, right? So what we did was we for a given service, what we do is we do some profiler runs. So in order to identify what is the test coverage we have for a given component, we do some profile runs. So we use for example, most of the Java applications use Jacoco. So we enable Jacoco, that profiling, and then we trigger test runs for a given runtime, right? So then we collect the code coverage reports for them, right? And then we create a product code to test code mapping. So when you generate the Jacoco test code reports, it actually tells you this particular .java file was actually touched by these test cases. It gives you that, right? So this data is not readily available. It's not like, okay, you can just take and consume. No, we did some reverse engineering on top of it, where we said, if a file is being touched by this code, then why not, if a PR is touching .java file, why not run the corresponding test, right? So that was the idea. So if you see, we take the product parcels and then we create the mapping JSON file, which creates the product code to the test code mapping, right? And then we are storing that in the S3 buckets. And for a given PR, and again, if you see, where are we using LLMs? It's like we are using those mappings to further enhance the blast radius of the testing. It's not like always these test cases will find the bugs, right? So it's always possible you have to run some test cases around that feature. There might be some features which are integrated along with that. So you might have to run those as well. So we are using AI to identify such type of tests, and then the enhanced test coming from them. And let's say if you raise a PR from, you raise a PR, right? So we have a tier called which, predict CI tier, which triggers those tests as a tier-based testing. Then we deploy cluster, we trigger tests. Then it generates the list of test cases to run. So if you see, this test cases is already come from the mapping. So we identify that what test cases have to be run for a given PR. Instead of running 1 million test cases, just run 25 test cases. We were able to do this. We introduced a bug. What we did in the hackathon was to actually introduce a bug in the PR. And from the millions of test cases mapping, it picked 25 test cases. And in that 25 test cases, which were run, it was able to find that bug, catch that issue, right? So this is where we use when we merge the test cases. One is the AI generated test cases list, which it feels is important.
These were unit test cases you're talking
No,
about?
integration tests.
Okay.
These are full integration tests. This involves creating clusters on AWS, GCP, Azure. We are available on all three. We have data centers as well. We can do it, or in-house cloud. This is possible for entire system test, integration test. These are full-fledged tests where you create something in the workflow, everything gets validated. It's not unit test, it's complete integration test. And then finally, the integration tests are run. We use Python PyTest for running our tests, and then that tests are inherently used. We use something called Quanta for internal dashboarding. Those are again published. Let's say if there is a bug, instead of running 1 million test cases, there is always flakiness in tests, right? So we're also working on a project which identifies flakiness in test cases and automix. We call something called as auto healing test, right? So we are working on that. So now what happens? The noise is reduced from 1 million to 25. In 25 test cases, one test case is failing. Developer will be willing to check why it is failing. On the contrary, if you run 1 million test cases, if 20 are failing, nobody will care. They'll just pass, they'll override and then merge. So the idea was to reduce this noise, reduce it to 25 test cases, reduce the cluster footprint. In that one test case is failing, people will check they'll find, and then there is an auto triager which is built on top of it. So what happens if one test case is failing? Now there will be an auto triager, as I said, after 10 minutes it will run and it will exactly tell you why it has failed. There could be another PR which is causing that problem, or your own PR is causing that. If there is a Jira, it will tell you this is a Jira which is causing, and then it will automatically trash that test runs as well. So that is what you achieve using generative AI.
Thanks, Miss. One more question is related to the prompt engineering. So you showed that Excel, right, where the test cases are generated. So you must have created a prompt,
yeah,
to get that. So those are like fixed prompt, or that also are like dynamic?
No, it is not fixed. It can change because, as I said, right, we are using it for generating functional test cases, non-functional test cases. There could be something else, third use case, which we might know. So we have flexibility in that. You can just literally change the prompt and then immediately run in your local. So we have that tool. So you don't have to wait for any deployment. It's instant.
Thanks, Miss.
Yeah. Mm.
This goes to my question, which I had asked in the first session. If I have a huge data set coming in live, and you said that RAG is not essential every time, you can just do it via prompt engineering. So how do we do it? Because the data might not just fit
Yeah.
into a JSON format.
Yes.
So what is the approach for that?
Yeah, so good question. Actually, I was talking to my friend on the same, right? So as I said, RAG is not needed for every use case, yes. But provided the context you are passing is within the context window size, right? There is always a limitation, there is always a trade-off. So with LLMs, so with at least for Anthropic Cloud Sonnet 3.5 model we have used, the window size is 200K. That is close to 65 to 70 pages of document. Usually, most of the use cases we are trying to solve, they come under this. But as you said, let's say, Shantanu was saying, let's say I have 15 GB of log data. Now, how do I pass that as a context? No, you can't do it. You need to have a RAG for that. For the same reason, we have RAG, where from that log data, it will actually extract information which is relevant. Then you pass that as a context to the LLMs. So there are limitations, and we have to see what we have to do, right? So if it is less than context window, definitely you don't need a RAG. You just pass it as a context. It works.
That's
Yeah.
understandable, yeah.
Yeah.
Because there can also be some historical data which you want to scan
Correct.
before you give answer.
Yeah.
Okay, thank you so much.
Yeah.
I'll request Venkat, please come forward. He is Director of Product Supportability at Cloudera. I'll request him if you want to say a few words just to summarize the event and then give goodies to the speakers.
Okay. Hello, everyone. My name is Venkat. I work with Umesh. So in our team, for about a year or so now, we've been working on generative AI as a technology. Our work mostly involves in, we are developing application for support, which means it's a direct application for generative AI. We take all the documentation, knowledge bases, etc. So a gist of what Umesh told us today is what we are doing. We have a wider scope actually to do. And as the other Umesh also spoke, there's a lot of initiative happening within Cloudera on generative AI. So as Umesh clearly explained, AI is not going to directly replace, but people who are not going to use AI will get eventually replaced. So it's super critical for all of us to understand generative AI. It is no more a rocket science. It's very much commoditized. So in case if some of you haven't tried using generative, have all of you used generative AI in some way or other? Is there anyone who has never used? I'm not talking about ChatGPT, but developing something using generative AI. Okay. You have already done, right? Or you haven't done? You haven't developed any application using, have you developed application using generative AI? You have, right? I'm asking who hasn't. Yeah. Okay, so if you haven't, it's fairly simple, fairly easy. Please go ahead and try. One of the idea of having Umesh, Umesh's idea is to come and talk about RAG is so that you understand what is RAG. And RAG is one of the easiest way for us to develop applications. And you don't have to necessarily use CML or DigitalOcean or anything at all. There are easy notebook tools which you can use to go and quickly build. You can drag and drop and build. And generative AI, of course, is just one part of it, right? There are several AI which has been traditional, like machine learning and others. So it's super critical for us to understand. Having such a meetup is fantastic because we come and express our ideas, our experience, and also ask questions, which will clarify, right? So I wish we have more topics like this. Thank you, Digital Ocean and folks from Cloudera to setting up this meeting and talking about generative AI and other technologies.
Thank you so much, Venkat. This recording will be published at our meetup page, Future of Data, and at LinkedIn as well. If any one of you is interested in collaboration or presenting a talk, please do reach out to me.